This video is on how to write your IB Physics IA. First, do a few things. Go on the internet, download this PDF, 125 Physics Projects for the Evil Genius. Okay. Says it's by Jerry Silver. Also download this PDF, 300 Stimulating Ideas for IB Physics Practical Investigations and EEs. You could go to pdfdrive.com and hopefully these PDFs are there. If you browse these two PDFs, hopefully you'll get a few good ideas for your IA topic, even your extended essay topic, if you're interested in doing your physics EE or your EE in physics. Please go on the internet and download as many IB physics IAs as possible. Because if you read 2 or 3 IAs for each of your classes, you'll get a good idea of how an IA should look like and how it should read like, and the contents in those IAs. Ask your teacher if they have any IA samples and to give them to you, and then give them to your friends, and hopefully your friends will give you theirs. You should have IAs for all of your classes, and an EE. A few EEs for the topic you're doing your EE in. So do watch and take notes on these videos. These are all available on YouTube. Okay? Okay, so ask yourself this question. What do you want to investigate? Why is this of interest to you? Why do you want to do this? This will help you in your introduction. Question 3, how does it relate to what is taught in this class? Which chapter or section is it from? You should know this because you're going to have to write down background information in your introduction. Question 4, this is very important. What is a research question? Because you're going to ask a question and you have to answer it. Don't just write an IA and not answer a question. Okay? You're going to do a lab most likely because those are the easiest IAs to do. You need a dependent variable, independent variable, control variable, or plural, dependent variables, independent variables, control variables. So now you're kind of getting an idea of what the lab is going to look like. Okay, put at least one source. It could be from the internet, it could be a book. Remember, your extended essay, you're going to have many sources. For your IA, you're only going to have like 1 or 2 sources. You don't need many sources for your physics IA. List all the equipment or materials needed for your IA, because if you need something like a time machine or a lightsaber or a super star destroyer, you might have trouble finding that. So make your list now. Okay. Which or what information are you going to collect? What will be on the horizontal and vertical axis of your table in the raw data section? Okay. Draw and label a table. Okay. So I'll give you an example later, hopefully, but maybe on the horizontal table, you're going to have 1 meter, 2 meter, 3 meter, 4 meter, 5 meter. And on the vertical, it's going to be something like trial 1, trial 2, trial 3, trial 4, trial 5. And then in the table, you're going to fill out something like time. Question of what will you label as your horizontal and vertical axis of your tables and graphs in your process data section? Okay, draw and label some tables and graphs. Of course, now your tables should be empty, but you should start labeling the horizontal and vertical of your table and graphs, just so you get an idea of what exactly you're going to measure. So that was IA homework 1. Here's IA homework 2. Step 1, make sure IA homework 1 is completed and approved by your teacher. Step 2, look at other IAs which are available online. Download as many as possible. Step 3, before you begin the experiment, complete all the sections until the results/raw data section. You'll see what I mean coming up, hopefully. Step 4, conduct your lab and get some data. Step 5, after you complete your lab and get some data, then continue with the results/raw data section and complete your IA. Step 6, go over the mark scheme and make sure you are receiving full marks on all the sections. Step 7, get your IA edited by your peers, classmates again and again. Look at other IAs which are available online. Suggestions, make your IA look professional and neat. Make sure your IA looks professional and neat. Read IAs of other students and get an idea of how your IA should look like and read like. Have more than one person read and critique your IA. Read the IAs of your friends and classmates and give them suggestions. Save and upload your IA in PDF format so all of the equations show up, because sometimes equations do not show up correctly when another version of Microsoft Word or text document program opens your file. So begin your IA on the next page. Here we go. So have the title of your physics IA, and your title should be a research question, okay? What is the acceleration of gravity near the surface of the Earth? That's an example. What is the specific heat capacity of salt water? That's another example. The reason why your IA should be a research question is because it's easy for you and the reader to quickly identify what exactly you're trying to solve. You'll have your candidate code number and physics internal assessment. Okay. So this will be on your first page here. You need an introduction. Why are you choosing this topic as your IA? Have a catchy introduction paragraph here. Mention personal significance, interest, or curiosity. So for example, some people would always talk about how solar energy is going to power the future. Is this even possible? So I'm going to see how much solar energy I could get to convert to electric energy and see if this could power the city I live in and the square meters that I need for solar panels. Okay. Have physics background information here. If you have questions, then if you have equations, then define each variable. Cite all physics information like equations and definitions in the bibliography section. Unless you come up with the equations yourself, you must cite all equations. Define the meaning of each variable. If you do not cite the equations or the meaning of each variable, then turn it in. We'll consider this as plagiarism. Mention the figures, tables, and graphs in your IA in the text before you show them. For example, figure 1 below shows the materials used in the lab. Write your lab/IA report as if the reader has no idea what you are writing about and everything is new to her or him. Be very detailed in the physics and all your steps. So not everybody knows what you're writing about. Please do mention as much physics as possible. Don't say, well, everybody knows that. Well, I thought you knew that. You're going to lose a lot of points. Next heading should say research question. This section should have only one sentence, the research question. So all of these things in bold and centered are like titles of the section. So do not change this word introduction. Okay. Write stuff below the introduction. Do not change this title research question. Just write your one sentence here. Do not change this title hypothesis. Okay. This section should be short. It can have only one sentence. Here's an example. I'm predicting that as the temperature increases, the resistance will increase to the power of 3. Okay. So R is proportional to T to the 3rd power, or KT to the 3rd power, where K is a non-zero constant. Okay. Next section, variables. Typically, this section should have 3 paragraphs with 1 sentence for each paragraph. The independent variable in this investigation is, the dependent variable in this investigation is, the controlled variable in this investigation is. Those are your 3 sentences or your 3 paragraphs. Or you could say this. In experiment 1, this was my constant. In experiment 2, this was my constant. In experiment 3, this was my constant. So now you're having different constants. Like you might have constant temperature, you might have constant pressure, you might have constant volume. You see what I'm getting at? PV equals nRT. Okay. Next section, materials. You should write something like the following materials will be used to conduct this IA. Okay. So just in bullets, you should mention all of your materials. Mention the uncertainties of your measuring instrument. So if you have a ruler, something that measures the mass of an object, list the uncertainties. Okay. You should write something like the materials used in this lab are shown in figure blah below. You must have a figure or many figures in this section of all the materials used in the lab. You could easily write something like all the materials are shown in figure 1 below. So one figure, all the materials. Next section, procedure to collecting data. The following steps will be taken to conduct this IA. Step 1, Step 2, Step 3, Step 4. Okay. The setup of the experiment is shown in figure something below. Okay. So have a photo of yourself in the IA. For example, have a photo of the lab setup with you in it pretending to conduct the lab. So your lab partner can take a photo. Or you can have a photo of yourself with the lab materials here. Excuse me. Excuse me. So you must have a figure of the lab setup in this section. The setup of this lab is shown in figure something below. Okay? That's important. So I just wrote it twice, I apologize. Okay? We need a procedure to collect the data. Okay? Next section, ethical and safety concerns. Okay, if there are no ethical or safety issues, then type something like, there were no issues with regards to ethics or safety when conducting this IA in this section. Next section, results/raw data. There should be at least one table in this section, include units, include the uncertainty, mention the table, and describe what information is in the table before you put the table in the IA. So, for example, table number 1 below shows the something. Okay? Column 1 shows the something. Column 2 shows the something. Row 1 tells the something. Row 2 tells the something. So something like this. You see I have time here on my horizontal, plus or minus, that's the uncertainty. On my vertical, I have height, plus or minus the uncertainty. So this looks like I'm going to drop something from 1, 2, 3, 4, 5 meters, and I'm going to measure the time it takes to reach the bottom. Okay? Something like that. So I did not even have to conduct the lab to finish all of this. Once I start doing the lab, I could start putting these numbers in. But up until now, like I said, I don't have to do the lab. And you should do all of this before you do your lab, because you'll understand what kind of data you need to collect. Many, many times a student told me he or she was going to do a lab. Once they start writing the lab, they tell me, teacher, I'm going to change my topic. And I understand why they're changing the topic, because they've started writing their lab and they realize that it's unrealistic. So do this. Once you complete writing everything up to here, have your classmates or your teacher read your IA, and they'll give you good criticism. And you'll even understand if your IA is realistic to write or to complete. So once you complete your raw data, once you put numbers in, you can continue. So you could do data processing. This is where you calculate averages or take the information from your results or raw data section and put them into equations. Okay? There should be at least one table in this section, include units, include the uncertainty, mention the table and describe what or which information is in the table before you have the table in the IA. Have at least one graph in this section. Label the X and Y axis of the graph, or the horizontal and vertical. Have a best fit line or curve. Microsoft Excel can draw a best fit line or curve. Make sure you're including units everywhere. So write something like table number 3 below shows the, graph number 2 below shows the, and then have your table, then have your graph. After the data processing section, have the conclusion section. What can you conclude from this lab? What did you learn? So use the terms directly proportional and or inversely proportional in this section. That's super important because you learn those terms in chapter 1, and that's what the reader's looking for. Use the terms uncertainty and standard deviation in this section. So, example, in conclusion, if the mass of the object increases, then it takes a greater force to move the object. This means that the force of push is directly proportional to the mass of the object. I just use the term directly proportional. Here's another example. In conclusion, the acceleration due to gravity near the surface of the Earth is 8 meters over second squared. Okay? That's what I concluded from the lab. That's what I learned. Okay? So compare your numbers or results to work of another paper. So example, if you are determining the specific heat of fusion of chocolate, then compare your results or numbers to those from another book or research paper or article or website. Here I said the acceleration due to gravity near the surface of the Earth is 8 meters over second squared. So now you're going to compare that to the text set, what it says in your book. It's 9.81 meters per second squared. So what's the percent error between 8 and 9.81? Next section, we're going to talk about errors and limitations of the investigation. So mention the terms random error and systematic error. Mention the terms high or low accuracy and high or low precision. So example, I did not have accurate materials to measure the time because a stopwatch is not so accurate. This is a random error. So I just mentioned the term random error. That's the key word the reader is looking for. Example, the force of air friction was too large. This is a systematic error. Okay? So I just mentioned the term systematic error. That's big. Okay? That's what the reader is looking for. And these are chapter 1 terms. Random error, systematic error, high, low accuracy, and precision. You need to have a section called suggested methods for improvement. For example, use a light gauge to measure the time, or conduct the lab in a closed room to decrease the amount of air friction. Do not say use better instruments, because use better instruments is vague. You have to mention specifically which instruments you need to use. Next section, bibliography. Okay. No Chinese, English only. Translate citations to English. Unless you come up with the equation yourself, you must cite all equations. Cite the meaning of each variable. If you do not cite the equations or the meaning of each variable, then Turnitin will consider this as plagiarism. Highlighted in yellow. When you are citing the website, do not just copy-paste the website. Go online and find out how to cite a website. So this owl.english.purdue.edu website, it's very popular, it's very easy to use. There are websites which will automatically cite a source for you. So make sure you could use those. Make sure you correctly cite. You could ask your English teacher if you're citing things correctly. You should learn how to cite correctly. So remember, do not change these titles, these headings. As long as you have something like a few sentences written under each of these headings, you could easily get at least a 4 or a 5 on your IA. Of course, your goal is to get a 7, because it's worth 20% of your grade.